Hello! Today I want to show you a proof for the Pythagorean theorem. This famous theorem that states that in a triangle with a right angle in it, which looks like that, and the right angle maybe here, and the sides named A, B, C, that for these sides the following equation is valid. A squared plus B squared is equal to C squared. And I want to show you a nice and short proof for that. So let's go. First you have to, if anyone gives you a triangle with a right angle in it, you have to copy it 4 times. So maybe someone gives you this. Okay, and the sides named this way. Side C is the one side in front of the right angle. Okay, now we copy it 4 times and we form a new geometric structure of it, a square. I will do that on the board. Okay, now we have this new square made of a copy, of 4 copies of this triangle. Accordingly, of course, it's because I'm not very good in freehand painting. It's not a very nice square. These are not very exact copies, but you can form a square with every triangle like this, and a square like this with every triangle with the right angle in it. And of course, we can see that there, in the middle, there's another square, because we have right angles here. And the length of the square, the side length, is C. You could now ask, are these angles really right angles? And yes, they are, because if you name this angle alpha and this angle beta, you know that following is valid. You know that alpha plus beta plus 90 degrees is equal to 180 degrees, because this is a triangle and the sum of the angles in the triangle is always 180 degrees. Okay, so and if you subtract alpha and beta on both sides of this equation, you get 90 degrees is equal to 180 degrees minus alpha minus beta. Okay. In our square we have alpha here, 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 and here. And we have beta here, here, and here. And of course, we'll have it here too. And this angle, for example, is 180 degrees. If we subtract alpha and beta from 180 degrees, we get 90 degrees. 180 degrees minus alpha minus beta is 90 degrees. So this angle is 90 degrees, as same as this, this, and this. So this is indeed a square. This small square inside has the size, the area of C squared. And the big square, this one, it gets a bit messy, but will be okay. This big square has the area A plus B squared. A plus B squared. So this big square, the size A plus B squared, is of course equal to C squared, this area, plus the area of all these triangles. So we have 4 triangles, and each of them has the area A times B half. Okay, now we have an equation, and we work a bit on this equation, and then soon we will get this equation, what we want to show. We have to evaluate this. This is nothing else than a plus b times a plus b, and on the right side we have c squared plus 4 times a times b half, so we have 2 times a times b. Okay, this is nothing else than a times a is a squared, a times b is a times b, b times a, and b times b, b squared, is equal to c squared plus 2 times a times b. Okay, now we can see that we have 2 times a times b on both sides of the equation. So we can subtract it, and what do we get? We get that a squared plus b squared is equal to c squared. So in every triangle with a right angle, this equation is valid if you name the sides like that. Thank you for watching.